Hello, ladies and gentlemen. Welcome to my classroom. Today I'm going to read Ratios and Reactions from your BSCS textbook, Level 2, Chapter 3, pages 126 to 128. Now, again, the title of this reading, and you may have it here in this piece of paper, is Ratios and Reactions. And what I want you to be able to get done after listening and reading this article is I want you to be able to understand how and why chemical equations are balanced. And you'll see that right here. I've got that for a learning target for us. So let's go ahead and get started. What does the mole have to do with concentrations in chemical reactions? Well, remember the concept of concentrations, all right? So when we talk about concentrations, we're really talking about how many particles are present in a mixture or a solution. So the more particles there are, the more concentrated it is. Scientists who construct the living space in the space shuttle certainly must understand the mole. They must remove the buildup of carbon dioxide, CO2, in the atmosphere of the shuttle. These NASA scientists must make careful predictions about the amount of CO2 to remove. Now, you'll notice on carbon dioxide, in carbon dioxide there is one carbon atom and two oxygen atoms. The little subscript 2 means that there are two oxygen atoms. They base their predictions on the amount each astronaut produces during the time he or she is in the shuttle. These scientists understand the mole and use that understanding to determine the amount of absorber, lithium hydroxide, LiOH, to include on the space shuttle to absorb the carbon dioxide produced by the astronauts. If you went to school, middle school in the Walla Walla Public Schools, in the 8th grade, you watched Apollo 13. And Apollo 13 was about this chemical reaction. They were trying to save the astronauts by figuring out how they could hook up their lithium hydroxide carbon dioxide scrubber with the round peg and the square hole setup. All right, moving on. Look at the following chemical equation, which represents the chemical reaction just described. Remember, the reactants are on the left and products are on the right of the arrow. Okay, so the reactants, change pens here real quickly. The reactants, those are the things that go into the chemical reaction, the chemical compounds that go in. So in this case, carbon dioxide is a chemical compound that goes into the reaction, and lithium hydroxide is another compound that goes into the reaction. Reactants are the things that come in, products are the things that come out. So lithium carbonate, Li2CO3 solid, plus H2O, which is water, in the liquid phase, is what comes out. Products come in, reactants come in, products go out. So, a balanced chemical equation gives scientists clues to the amounts of reactants that are needed for the reaction to take place. This reaction indicates that 1 mole of carbon dioxide gas reacts with 2 moles of solid lithium hydroxide, or LiOH, to produce 1 mole of lithium carbonate, Li2CO3, and 1 mole of liquid water, H2O. The number 2 in front of the reactant lithium hydroxide, LiOH, is called a coefficient. It works much like the coefficients in math equations. It affects everything that is with it. Is there a coefficient in front of CO2? One is understood, but is not written. Now let me go over this coefficient thing again. So if I go back up to the lithium hydroxide right here, 2 lithium hydroxides. What that 2 means that there are 2 lithiums, and it's like a multiplier, 2 oxygens and 2 hydrogens. So the coefficient is a multiplier that is out in front of the chemical compound. Again, 2 lithiums, 2 oxygens, and 2 hydrogens. And there is a coefficient in front of the carbon dioxide. It's a 1, but we don't generally write it. There's a 1 out here, and there's a 1 right there. Okay, so now we're down here with the molar ratios paragraph. The molar ratios of the particles in this reaction are 1 carbon dioxide to 2 lithium hydroxides to 1 lithium carbonate to 1 water. So basically, it tells me that for every 1 mole of carbon dioxide, I need 2 moles of lithium hydroxide. Or for every 1 mole of carbon dioxide, I get 1 mole of lithium carbonate, or 1 mole of water. It works backwards too. For every 1 mole of water that I get, it takes 2 moles of lithium hydroxide to make it. So those molar ratios are going to become really important here in the next day or so. As scientists prepare for a space shuttle mission, they know that for every 1 mole of carbon dioxide, 6.02 times 10 to the 23rd carbon dioxide particles produced by the astronauts, they must provide 2 moles of lithium hydroxide. Now, 2 times 6.02 times 10 to the 23rd is going to be 12.04 times 10 to the 23rd, because 2 times 6.02 is 12.04. So again, for every 1 mole of carbon dioxide, 6.02 times 10 to the 23rd carbon dioxide particles produced by the astronauts, they must provide 2 moles of lithium hydroxide, 12.04 times 10 to the 23rd lithium hydroxide units. Knowing these mole ratios is essential to the safety of the astronauts aboard spacecrafts. They need to be able to know how much lithium hydroxide scrubber they're going to need. Otherwise, the carbon dioxide builds up and they can't breathe. This equation is balanced with coefficients. Coefficients show the same number and kinds of atoms are present at the beginning of the reaction in the reactants as at the end of the reaction in the products. This supports the law of conservation of matter, which states that matter is conserved in ordinary chemical and physical changes. Count the atoms in this reaction to verify that it supports this law. Set up a t-table as shown in figure 3.6 to check if the equation is balanced. Now, let's just pause for a quick moment before we do that. The law of conservation of matter, I don't want to gloss over that. What that means is that we cannot create or destroy atoms in chemical reaction. The number of atoms that we have at the beginning of the reaction must be equal to the number of atoms that we have after a chemical reaction. So let's take a look at this equation now. I notice that there is 1 carbon there, 2 oxygens. 2 times lithium, there's 2 lithiums, 2 times oxygen, 2 there, 2 times hydrogen, 2 there. Now let's look at the product side of the chemical reaction. There are 2 lithiums. Oh, look, lithium's balance. 1 carbon. Oh, carbon balances. 3 oxygens. But, there's 4 over here. I have to look at that. There's 3 oxygens here. Oh, but I've got the water to look at. There are 2 hydrogens here and 1 oxygen. So 1 oxygen plus 3 oxygens is 4. On the reactant side, I've got 2 oxygens and 2 oxygens for a total of 4. So you can see here on the table, kind of summarizes that. On the reactant side, 1 carbon, 1 carbon. 2 lithium, 2 lithium. 2 hydrogen, 2 hydrogen. 4 oxygens, 4 oxygens. Chemical equations have to be balanced. We have to have the same number of atoms on the reactant side and the product side because of the law of conservation of matter. We cannot create or destroy atoms. If you must balance an equation, only add coefficients to balance it. That is so important. Only add coefficients to balance it. Never change the subscripts to balance a chemical equation. Look at the reaction of hydrogen, H2, and oxygen, O2, to produce water. So you'll notice that we have 2 hydrogens plus 2 oxygens is going to produce 2 waters. Count the atoms to decide whether the equation is balanced. You should see that it is not balanced. So just pause for a moment and count while we wait. Okay, you should have noticed that on the left side there are 2 hydrogens here, 2 oxygens, 4 hydrogens here, and 2 oxygens. Well, you'll notice that oxygens balance, but hydrogens don't. So in the next paragraph, it would be easy to balance the equation by just adding a subscript 2 to the end of H2O. Did you try that? If you did, you just turned water, H2O, into hydrogen peroxide. Hydrogen peroxide is toxic, very different from water. That's what hairdressers will put on hair to bleach it. It's also, it kills bacteria. So hydrogen peroxide is it's not the same as water. It's close, but it's not the same. You cannot balance a chemical equation by changing subscripts because that changes the substance. Only use coefficients to balance chemical equations. The balanced chemical equation should look like this. We put a coefficient in front of the hydrogen. So when we do that, let's look at it now. 2 and 2, 4. 2 oxygens. 2 times 2 is 4, and 2. We have 4 hydrogens on the reactant side and 2 oxygens. We also have 4 hydrogens on the product side and 2 oxygens. And you'll notice that the little lower subscripts here, gas, gas, gas. So hydrogen gas plus oxygen gas will produce water gas or water vapor. The ratio of the reactants and products in this reaction is 2 moles of hydrogen to 1 mole of oxygen to 2 moles of water. The balanced chemical equation does not tell you anything about the rate at which the chemical reaction will occur. So it doesn't tell you how fast it's going to happen, but it just tells you the ratio at which this will occur in. To get 2 moles of water, I have to have 2 moles of hydrogen gas and 1 mole of oxygen. So again, it does, however, give you information about the relative amounts of reactants needed and the amounts of products to form this reaction. So I hope this helps you understand why we have to balance equations and how you do it. Clearly, you're going to need some more practice with balancing an equation, which the stop and think right after this reading is going to help with. All right, let Mr. Ahrens know. Let me know if you have any questions. All right, have a great day.